Okay, I think we can go ahead and get started. So my name is Dylan. You might recognize my voice by now in my little Zoom picture. I work at HPRC at the help desk. I've worked there for a couple years now, and I've been doing these primers. They started about once a week, and now they're like last week we had multiple primers throughout the week, and this week we have data management practices. So basically managing data on our clusters, Ada and Terra specifically. So if you've been to a primer before, you kind of know the deal. It's an hour-long session. Um, I'm here. Braden's in the chat to help out with questions. So if you have questions, feel free to just drop them in the chat. Otherwise, we're going to go ahead and get started. So let me unpause my screen. Okay. So yeah, you can follow along with MOBA Xterm if you want. If you have a terminal application, you can follow along with that too. I'm on a Mac, so I'm just going to use my terminal when I do connect to the clusters. I'm going to activate my VPN real quick. Okay, so let's get started. So logging into the system by now, you're probably familiar with logging in to the cluster. So when we log into them, we use SSH Secure Shell. It's freely available on Linux and Unix and Mac OS hosts. It's built into the terminal that's available. If you're on Windows, you're going to want to use an SSH application like MOBA Xterm or PuTTY. PuTTY works just fine too. MOBA Xterm is what we recommend everybody because it's a little nicer, a little easier to use, more user friendly. PuTTY works just as fine too. It's just very bare bones. And when you're connecting to the clusters to Ada or Terra, you need to be connected to the campus network, which means if you're off campus, like most of us probably, like myself included, you need to connect to the VPN. So Braden posted the link to the VPN, the IT VPN page. But this is also a valid link right here. It's basically sets up, helps you set up the VPN. So using SSH. So if you've been to one of these courses before, you're probably familiar with SSH. SSH is just the command line utility for creating a secure shell tunnel to whatever target machine you're going to. Today we're gonna log into Ada and we're gonna do some of the exercises from Ada. You could do them again from anywhere, but in my case, I'm just gonna use Ada. So over here on the terminal, I'm just gonna say SSH -y. I'm using the -y flag so I can have graphics if I'm going to use graphics later, which I might or may or may not, but I just always enable it by default. And then my net ID, which is just Dylan at, and then the target, so ada.tamu.edu. Enter. It's gonna hit me with this policies thing. I'm gonna enter my password real quick, and you'll notice that it doesn't. In Linux, when you enter your password from the command line, it doesn't give you like any asterisks or black dots here. It's reading your input, but it's just not showing anything. That's like a security feature. Hit enter. My password was successful, so now I'm going to authenticate with Duo. Okay. And there we go. So now I'm logged into Ada. Make this a little bigger. Ada 6. Connected with Ada 6. And I'm going to Control L, clear my screen. If it's your first time logging in, you're going to see this little message. It's going to say host key not found from the list of known hosts. Are you sure you want to connect? It's basically just saying you've never connected before. Are you sure you want to connect? And then you say yes, and then you connect. Yeah, and then it's going to add Ada to the list of known hosts and ask for your password. Okay, perfect. So good data practice. The rule of thumb: 1 is none, 2 is 1. So you want to keep multiple copies of important data, and this is really, really important. If you walk away learning one thing from here, it hopefully should be this. So when I first got to A&M, A&M didn't have we didn't have team drives. So I didn't use Google Drive nearly as much as I use it now. Now Google Drive is like my main storage for everything because it's accessible everywhere. But back then, I just had a thumb drive, like a little 64 gig flash drive that I kept in my backpack. I remember taking like 221 in one of the intro classes for computer science, and I lost my homework because I lost my flash drive. And that was a horrible, horrible, horrible time because I spent a lot of time on that programming assignment. So now I save everything to the cloud on the Google Drives, and then I have local copies on this Mac that I'm on right now. So always have more than one copy. Backup your data. I had to learn that lesson the hard way. So, okay, data on our clusters, Ada. So there are limits on the amount of data you can have on our clusters. We call this your quota. These limits are on disk space and file usage. So you can see these quotas, you can view these current quotas with the command show quota, and this is what the output looks like. So to the terminal, I'm gonna say show quota, and it's gonna give me 1, 2, 3, 4, 5 columns. The first tells you which file system, the next tells you how much of that file system is being used, and then the third is the limit, and then the fourth column is the file, which is the second limit, and then how much of the files are you using. Sorry, it's reversed. How many files are you using versus what the total limit is. So again, the two limits are your disk usage. So this is measured in either gigabytes or terabytes, and then how many files you're using, measured in thousands. The default is 250,000, but my scratch is at 1 million because I had it increased. So we have a slide right here. This talks about the default limits of the 3 file systems. Home, your limits are going to be 10 gigs or 10,000 files, whichever you hit first. Your scratch is going to be 1 terabyte or 250,000 files, whichever you hit first. And then your tiered is going to be 10 terabytes or 250,000 files, whichever you hit first. Important to remember, tiered is only on Ada. So Terra does not have a tiered file system. If you need more space than these default values, specifically the default values for your scratch or your tiered, send us an email and we can work to help accommodate your request. With the asterisk of we get a lot of requests, so we try our best to I think most of the time we could accommodate reasonable requests. But if you're asking for like 25 terabytes in your scratch, you might have to wait a little while we sort of procure that space, because we do need to make sure that everybody else has space. Yeah, so you can just send us an email. So let's talk about the difference between these file systems. Home is not backed up, and the reason we don't back up home is because home is not expanded, and the reason it's not expanded is because we back it up. We have to limit people's home file space to 10 gigabytes because we do back it up. And if we expanded people's homes, then we'd have to back up that too, and then that gets ridiculously large, ridiculously larger than it already is, and it's already ridiculously large. So that can cause issues. So we will not back up, or we will not expand your home, but we will back it up nightly. So if there's ever some kind of super terrible unforeseen circumstance, you could email us and we could work with you to see what we could do to restore some files. Your scratch and your tiered. Your scratch is going to be your high performance storage with those little air quotes that you can't see that I'm doing. That's typically where people drop all their data. So you log into the cluster, you're going to be working on a machine learning, you're going to be training some neural nets or something, you're going to train some models. So you need to upload a whole bunch of data sets to the clusters. You'd probably want to upload them directly to Scratch, seeing as they will probably be larger than 10 gigabytes. Typically data sets are kind of large. So you upload them to Scratch. And if you need more space than the 1 gig or 250,000 files that we gave you by default, send us an email and we could work with you. It's not backed up. That's important to remember. The tiered file system is the archival file system. So that's for your data and your models and your results that you are finished working with, that you are not actively using, and that you can kind of put on the shelf for a minute. Maybe you don't want to delete it. Maybe you don't have the physical space like on your person to hold it somewhere. You don't have the hard drives to hold it. You can put it in tiered and leave it there for a while. The thing with tiered is that from the compute nodes, it can't be seen. So it essentially doesn't exist in the compute node. So it's literally only for storage. So think of tiered as kind of like your storage shelf, where you put your data that you're not actively working with. Also, it's not backed up, but it can be expanded. So if you need more space on your tiered, let us know. We can help accommodate that. Okay, so getting data to our clusters. We're going to talk about some graphical user interfaces for actually getting data to Ada and Terra in the last section of this class, of this little primer. But right now, I just kind of want to prime you guys on the fact that Ada has what we call fast transfer nodes. So fast transfer nodes are essentially login nodes that are dedicated to fast file transfers. They're named right here, Ada-FTN1 and Ada-FTN2. So you can log into them by saying, this is actually incorrect. It should be, I'll show you right here. So from the terminal, I'm gonna, let me just SSH from here. I'm gonna say SSH Ada-FTN1.tamu.edu. And when I hit enter, I see the same wall of text that we get. Enter my password, duo authenticate, there we go. And now I'm logged into FTN1. So the difference between FTN, I need to change this. The difference between FTN1 and 2 and the login nodes is that these have 40 gigabit capability, so they have a faster internet connection speed for making these uploads and downloads. And there's also no programming environment installed. So these are for transfers only. So the reason we don't have a programming environment installed, and what I mean when I say programming environment, I mean we don't have like compilers and stuff here. We don't have those like math libraries and whatnot for like, so you can't execute your code here. This is just for transferring your data. So now that I've logged into FTN1, I could rsync some data from my local machine to here. There you go. I can't type today. Local file to home. So I could transfer files from my local machine, local being my MacBook, and then put it in my home. So whenever you're making large transfers, you'd probably want to use the fast transfer nodes. And so to access them, again, their host names are just ada1-ftn.tamu.edu and ada-ftn2.tamu.edu. So basically, instead of just saying ada.tamu.edu, you're just adding the -ftn and then 1 or 2. This one should have a 1 on it. And it'll take you to this fast transfer node. In addition to the faster internet speed, internet connection, and the lack of programming environment, these fast transfer nodes also do not have that 1 hour process limit that the login nodes have. So if you're on a login node and you're making a download from a login node, from your local machine to a login node, if that process runs for more than an hour, so 59 minutes, it's gonna die. That is disabled on these 2 nodes, with the assumption that if you're transferring data, the data transfer might take longer than an hour, so that's okay. We don't want to punish you for that. So these transfer nodes do exist on Ada. There is one on Terra, but it's not publicly accessible in the way that these are. To access the transfer nodes on Terra, you'd use Globus, which we will talk about later. But yeah, so that's the important thing here. For transferring data to Ada, if you're going to use the command line, you probably want to log into the fast transfer nodes, which are named ada-ftn1 and ada-ftn2.tamu.edu. This should be removed right here. Okay. Oops. Okay, Terra. So let's talk about Terra. Pretty much the same for Terra. So we're not going to spend too much time on it. If you're familiar with the quotas on Ada, they're the exact same on Terra. The one key difference being that Terra does not have the tiered file system. It's only got the home and scratch file system. So again, your home is going to be backed up. It's going to be limited to 10 gigs or 10,000 files. Your scratch is not going to be backed up. It's going to be limited by default to 1 terabyte or 250,000 files. Your scratch can be increased. Send us an email if you need that. Yeah, that's pretty much the same for Terra. This slide just kind of elaborates on that. Home 10 gigs, 10,000 files. Scratch 1 terabyte, 250,000. Same deal here, just no tiered. Okay, so let's talk about some command line tools. We're gonna talk about these 5 command line tools: copy with CP, removing with RM, SCP for secure copy or remote copy, SFTP for secure file transfer, and then tar archiving. And then after that, we're going to talk about, I'm going to show you guys some solutions for file transfer using the GUI. So all of these are data management tools that you could use from the command line. They're basically really basic Linux commands. So back to the terminal, I'm going to log out. So my connection to fast transfer node 1 was closed. I'm back on Ada 6 because remember I SSH'd from Ada 6. So I was basically 2 shells deep. Now I'm just 1 shell deep. I'm going to clear my screen, and then I'm going to cd to my scratch directory. You could do this from wherever. I'm just going to do it in my scratch because, okay, maybe not. I'll do it from my home. I thought I had less stuff in my scratch. Okay, we'll just do it from home. That's fine. Okay, so the first command, cp copy. Copy does exactly what you think it does. It's going to make a copy of a file. So to use it, oh, I turned on my laser pointer. Awesome. Wow, I wish I'd figured out how to do this earlier. So to use CP, you just call CP, the command line tool. And then the syntax is going to go like this. So CP, and then the source file, and then the new file name. So the actual syntax, like the technical term, is going to be, this is going to be your source. And then this second argument is going to be your target. So by saying exactly like this, CP source file, new file name, this would copy, it would take this source file and it would make an exact copy of it with the name, new file name, whatever we want to put there. So let's go here and let's see, what files do I have to copy. Let's copy like we have a some file. What's in some file? Cat some file. Okay, so this is some example file that I had. Perfect. It works just perfectly fine. So I said LL to list all the contents. Here's some file. I want to make a copy of this because this is a super important text file with, I don't know, super important data. So I'm going to say CP some underscore file, and then I'm going to give it a new name, some file dash copy. Enter. LL again, and now I see some files right here, the original, and then some files the copy, and I know it was a copy because it was made June 9th today at 2:18, which is right now. So we made a copy. The cool thing that you can remember with CP is that you can give it a path name. So for example, I say CP some underscore file. So this is going to copy some file, and I don't have to just put the copy right where I'm standing. I could tell the copy where to be copied to. So I'm going to make a copy of some file, and I want to throw it into scripts, which is a directory. So it's a folder that just holds scripts. So I'm going to say copy some file, and I want you to put it inside of scripts, just like this. And let's name it. We'll name it the same thing again. Some file dash copy. Hit enter, and now I'm gonna LL scripts. So it's gonna list the contents of scripts. Scripts being this directory right here. And inside of scripts, I see some scripts, and then the copy of the file we just made. So really simple, making copies. That's how you do it. Use CP. Easy solution for copying a file onto the same machine. What about moving data between machines? We'll talk about that later, because next we're going to talk about removing files. So turns out that file that we just made was not so important, and now I want to delete it. So I'm going to Control L to clear my screen, LL again, and here I see this some file copy. Now I'm annoyed by it because I didn't need to copy it, so now I'm going to remove it. Removing stuff in Linux, you're going to use the rm command, rm being remove, easy to remember. Let me put a little asterisk with here, with this command. This completely deletes a file. So on Mac, on Windows, when you delete something from Finder or from Windows Explorer or File Explorer, whatever the Windows File Explorer is called, it typically sends a file to the recycling bin, and then you have a chance to like restore the file before it gets deleted permanently. Removing stuff in this form from the command line using the rm command deletes it permanently from the machine. It basically skips the if your Linux machine has a recycling bin, which most don't, unless you're using like a graphical, like you're sitting at a computer with a Linux interface, it's going to skip the recycling bin and just delete it entirely. So be careful using RM. If you want to kind of have a little bit of a safety net there, we recommend using the -i flag because there's no trash bin. If you add the -i flag to the RM command in such a way as this, RM space -i, and then the target you want to delete, it's going to prompt you prior to file deletion. So running this command right here, rm some file, is going to delete some file immediately as soon as you press enter, never to be found again unless you call the FBI and they dig through your hard drive using their FBI technology. Using rm -i will do the same thing, but before removing some file permanently, it's going to prompt you and say, hey, are you sure you want to delete this file? And then you can say yes or no, or cancel the command entirely. So useful when you're deleting a ton of stuff. If you add another flag to this called R for recursive deletion, you might want to add the I flag just so that you can delete everything. You only have to say RM once, but it's going to ask you every time. So let's see an example. We're going to say RM some underscore file dash copy. Again, notice I'm not using the I flag, so I hit enter and it's gone forever. So let's see what's in temp. Okay, temp is the file from my Linux course a while back. So Control L to clear the screen, L to list everything again. Here's the temp folder. I want to remove this. So I'm going to say rm -ri. So R is going to be recursive deletion, which is also how we delete folders. So, or it's how we delete non-empty folders. So temp is a folder, it's a directory, but it's not empty. There's stuff inside of it. I want it all gone. I don't care what's in it. We're just going to delete all of it. But because I'm a good compute citizen, before I delete anything, I'm gonna prompt myself for whatever I'm deleting, just so I don't accidentally delete. I don't know I don't know what would be so important. Something really important. Let's pretend there's something really important. So I'm gonna say rm -ri recursive deletion. Prompt me before you delete anything, and then give it a target. I'm gonna say temp. And you don't need the slash there, but the slash there, the slash shows up when I hit tab. Okay. So rm, I hit enter. Rm says, and this is the -i flag here. It says descend into the directory temp, and I'm going to say yes. Remove directory temp hg19, yes. Remove directory temp, yes. And then here we go. I'm back. Got my prompt back. LL one more time, and temp is gone. So from what RM told me, it deleted three things, or it deleted two things, but it prompted me 3 times. The first time it prompted me, it said, I found this folder, temp, do you want me to descend into it? And I said, yes. And that's the recursive flag. That's the recursive flag going inside, but it's the -i flag prompting me for deletion. And then the -i flag prompts me for the deletion of all the other files. So -i, important flag to remember when you're using RM. I still use it nowadays because I get really nervous and I don't want to delete stuff on accident. That's true story. I actually deleted my home directory one time, and one of my coworkers, Francis, is not very happy with me. This happened a long time ago, but good times. Yeah, so I always use the -i flag when I'm doing recursive deletion, especially. Okay, so let's talk about the next command line tool, SCP, secure copy. Secure copy sounds a lot like regular copy, but the difference here is that we're able to copy files between hosts on a network, hosts being other computers. So in our case, the hosts are going to be, the hosts would be my local MacBook that I'm working on right now, and the other host would be Ada. So if I wanted to copy a file from my local machine to Ada, this is the syntax I would use. We say SCP. Oh, by the way, it's called SCP. SCP stands for secure, and the secure comes from shell, because SCP is going to use SSH for data transfer. SSH stands for secure shell. So as you can see, it all ties back into each other at some point. So yeah, so secure copy. you copy the source file, and then you'll notice that we have a longer little path here. And so the syntax for this whole thing is, if you notice, this first part of the argument is the same thing that we gave to SSH. So when we said SSH, we said SSH netid at ada.tamu.edu. So we're already familiar with that. And then we add 2 little colons here. And then after the colons, we add a path. So the technical definition of this argument is the user you want to log in as at the host, so the computer you want to log into, and then 2 colons, and then the path to where you want to put the file, this file right here, source file. That's exactly what we're doing here. So this is just kind of a long-winded way of doing it. This is perfectly valid again. And the reason I wanted to show it is because if you work if you're working with a Linux machine in a Linux environment, I think it's good to understand how the technologies that you're using work. And so that's why we included this one. And then the next, I believe it's the next one, SFTP. So these are solutions to the problem, but there's nicer and easier, maybe more convenient ways to do these, which get wrapped up into the graphical user interfaces, where people write programs that do this interactively, so you don't have to type all this stuff out all the time. You can just kind of drag and drop. But these are the underlying technologies that those software are built on. So you would use this file, or you would use this command line utility to copy things from local to remote sources, like this example right here, from remote to local. So I could say SCP and then switch these 2 arguments around, and it would do the same thing. But except for right here, I would have to, in this case, netid home Dylan would be a directory, so I'd have to give it a file inside of this directory. So just 1 more slash and then some file. And that would copy from Ada to my local machine. Or you could do replace this whole source file thing with this whole same syntax, but netid at terra.tamu.edu, and then you could be copying files between 2 remote locations from a local system. I hope that makes sense. These are like I said, useful, but there's kind of other technologies that can solve this problem a little bit more efficiently. The one command line utility that I didn't include here, which I would have included, but the reason I didn't is it's called rsync, which I kind of alluded to earlier. Rsync is basically secure copy, but with better features. So think of rsync as MOBA Xterm to SCP's PuTTY. It does the same thing. Rsync's kind of a little bit more advanced, and it can be a little nicer. Didn't include it because rsync is not available by default on all systems. SCP is probably going to be same thing, but like with CP and RM. So these utilities that I'm including here are going to be the most broadly available. If you booted up a Linux machine tomorrow without doing any administration, you're going to have these available. So that's the idea. So let's talk about the next PuTTY-like technology. This one being SFTP. SFTP stands for Secure File Transfer Program, or protocol, depending on who you ask. And this case that we're going to use it, as an interactive program. It's secure because it uses SSH again, and the way you do it is you use it as if you're actually using SSH. So back to my terminal, I'm going to do Command T. I'm going to open up a new terminal. So this is Dylan at my MacBook Pro right here, logged into my local machine. And I'm going to say SFTP and then my netid at ada.tamu.edu. Hit enter and I get the same SSH prompt. Let's log in and duo our way onto the cluster. Approve. Yep. Okay, so now I'm logged in, but I don't have a little SSH prompt. I have an SFTP prompt right here. So this is an SFTP connection, whereas this connection over here is an SSH session. This SFTP session is for file transferring. So we have a whole bunch of commands which we could see with, if we say, I said help to get that right there. That gives us all this. But for using some really simple commands, we got some right here. We just do CD to change directory to move around, just like we would on our local, like on our shell, our secure shell. We can say git to download files, and it's going to download files where we SSH from. So I believe I SSH from my home on my, so just /home/Dylan on my MacBook. So if I say, let's say ls is going to clear CLS. Okay, I don't know how to clear the screen in SFTP, but I'm gonna list the contents, and typing ls right here lists the contents of my home directory. So let's download some file. So I'm gonna say git some underscore file. And then it says fetching the file, and then here it is downloaded. It downloaded pretty fast. And I'm gonna do command T one more time. I'm gonna do LL. And when I hit LL, I see right here, some file has been downloaded to my home, which is called users Dylan on my MacBook. So git downloads files, put will upload files. So I could put files from my home, and then to quit the connection, it's going to be by. You could kind of tell by the fact that the quit command is called by, that it's an older program. This is back in the days where we kind of thought that we could make these utilities more accessible by changing the language we use and make it seem like we're kind of talking to them a little more. That didn't really pan out so well, but that's SFTP. Again, I include SFTP not because you'll probably use it a whole lot, but because the programs that use it, CyberDuck, Globus, those sorts of things, they use SFTP as their underlying technology. So if you kind of understand the underlying technology, you have a better idea of how it's working. So if something ever breaks, you could be the cool person who kind of knows, or at least can understand the conversation about why it broke. So yeah, SFTP used basically like SSH. And then the most useful tool is going to be tar. So tar is the command line utility for archiving files. So basically, tar is for consolidating and then compressing, if you want to compress many files into one file. So the example that I would show you here is, let's use this scripts directory. So this scripts directory has a bunch of scripts that I use at the help desk. It's got a couple of really useful ones that are pretty much they're very important for doing things like monitoring other users' quotas and jobs and whatnot. So anytime we have a new worker, typically I would tar this scripts file up and then put the consolidated file somewhere where they can access it. They would download the file, unzip it, and then uncompress it, and then have all the files that they needed. So basically, tarring is taking many files, consolidating it into one file. If the many files are large, you can consolidate it into one file and compress it to make it smaller. In our case, these are just a handful of scripts, so it's not really that large. But you could imagine if you're transferring data sets, you'd want to probably compress them so they're easier to transfer and manage like that. So how exactly do you use tar? So tar is going to be the one that kind of throws off the general source target syntax. So this first example right here saves many files together into a single file. And that single file is going to be a file with the .tar extension, and we're going to refer to that as the archive. So again, when you create a tar, it's not going to give it the .tar extension by default. It is going to change its color to like Linux will recognize that it's an archive, but since we're using tar to create it, good computing practices dictates that we should name the archive whatever we're going to name it .tar. That the .tar extension just tells people, hey, this is an archive, and we created this archive using tar. There are other ways to make archives. So yeah. So let's go to our terminal, and here I'm going to say tar minus cvf and we'll talk about these flags in a second. And then, so the syntax for tar is going to be the name of the archive. So because we're going to tar up these scripts, I'm just going to name it scripts.tar. And then the file that we want to tar up. So in this case, we're going to give it a directory, so we're going to give it scripts. Hit enter. And then the output is going to say, okay, so I found scripts, and then this file, I found scripts in this file, this file, this file, this file, this file. It lists all the files that tar found. And then if I type LL again, you'll see we have scripts, and now we have a red or a different color. And in my terminal, it's going to be reddish, and it's going to be scripts.tar. So whereas scripts, we can CD into, and now I'm in home Dylan scripts. If I go back to my home, I can't CD into scripts.tar because it's not a directory. It is a, what does Linux think it is? .tar. It's a POSIX tar archive. So now we could send this single file off to someone who needed it, perhaps somewhere. And then they could run the opposite command being xvf. So the flags we use here were tar to open up tar, to call tar utility, and then -cvf. C says create this archive. V says be verbose. So everything you do, I wanna know what you're doing. That is this output we saw right here. Oops, where is it? Right here. All this where tar is saying, okay, scripts Derek job rec, scripts Derek lab add. That's tar specifically telling us what it's doing. And then, oh, sorry, the CF is to create the archive from these files. That's what that's saying. And then the verbose says, yeah, be verbose, tell me everything you're doing. Okay, and so then to extract from this archive, it's the same deal, but instead of saying C, we're saying X. So XF, extract these files, be verbose about it. So to prove to you that it works and that I have utter faith in Linux command line utilities, I will go here and I will delete rm -r scripts, oops, -ri scripts. Yes, 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 and yes. Okay, so I've deleted my scripts folder, which is very important for my work, so I can't not have that. So to reinstate it, let's pretend like I've just downloaded the scripts.tar file from another helpful help desk worker. So now to extract the contents of this tar, I say tar -xvf scripts.tar, hit enter. And then you'll notice when I say xvf, I don't have to give it a name. I don't give it a name because the files inside of this tar are already named. So as they extract, they'll just take their own name. So again, the xf is extracting all the files from this tar. The v is being verbose about it, so it tells me all the files that were extracted, which are the exact files that we put into it. I'm going to type ll again, and now I have my scripts back. Ll my scripts. Oops, that's not how you spell scripts. And all my files are back, thankfully. So I can continue having a job. So yeah, so that's why tar is very important. If you wanted to compress these files, so let's pretend like these weren't scripts, that these were in fact like data sets, like I said, larger data sets, you would use the Z flag. So creating a compressed archive, you'd go czvf. Again, and the order of these flags doesn't really matter. This is just kind of how I always remembered it. czvf. So create an archive from these files, be verbose about it, and then run these files through the gunzip compression algorithm. That's what the Z does. So your tarball, oh, also, if you do that, if you use the Z flag, you should probably name your archive again. This is important to follow good computing practices. You should name your archive.tar, so you know that it's a tarball created with tar. And then if you compress it using the Z flag, so use the gunzip compression algorithm, gzip compression algorithm, you should add the .gz extension as well. So it would say archive.tar.gz. So that tells whoever is downloading the file, oh, this is a compressed tarball. I need to uncompress it using the -c flag, that sort of thing. So that's what this example shows here. .tar.gz, you would extract it using xzvf, same deal. Archive.tar.gz, and then you would get the contents. In this case, our data set or our scripts, just like this. So tar, very useful for consolidating files, for sending files around to people. Highly recommend getting familiar with it. This slide does a really good job of kind of just giving you the basics of it. Yeah, so okay, let's talk about GUI clients. So there are many GUI solutions for file transfer. If you were following along on MobaXterm or you've downloaded MobaXterm, you've probably noticed on the side, so if MobaXterm is a big square, on the sidebar of MobaXterm, you have the SFTP side panel. That's really good for, it's really good because it's a little SFTP session right there on your sidebar. Duo kind of messes with it a little bit. So the two-factor authentication specifically on our clusters occasionally makes that a little wonky because, like I said, it's going to use SSH as one of the underlying technologies for making these transfers, and every SSH connection to our cluster has to be authenticated with a two-factor authentication with Duo. So occasionally you might get like a weird text box that pops up that asks like for Duo authentication in some weird way, but quirks aside, it's a very nice, quick and easy solution to your file transfer, especially if you just need to make one transfer every now and then and you don't want to have to type out these commands all the time. So MobaXterm's got it built in. You could also go to the top left of MobaXterm, in the sessions box, and you could start an SFTP session, which will look a lot like the SFTP sessions that you would see in WinSCP or CyberDuck. So WinSCP is an FTP, so a file transfer program client, protocol client, whatever you want to call it. WinSCP, the Win implies it's only on Windows. It is available on the library computers, I believe, at A&M. So it's one of those software that's kind of installed by default just about everywhere on the A&M campus. So if you want to use something that you're familiar with on your computer and on campus, if you ever don't have your laptop with you, and you have a Windows machine, WinSCP is a decent solution as well. It plays fairly fine with Duo. We have pages on our wiki describing how to configure most of these softwares with Duo in case you run into any issues. FileZilla being the prodigal son, which I miss dearly. FileZilla was the file transfer program that I used like religiously for all my file transfers to Ada and Terra and to the other computer science machines back when I was doing that stuff. And then November 6th or 4th came around and we implemented Duo, and FileZilla hates Duo. I remember scouring their developer forums for a while looking for solutions, and eventually, stumbling across other universities who had implemented Duo as well, and the developers for Duo, or the developers for FileZilla, basically said, we don't have plans to implement two-factor authentication in Duo. So you can use FileZilla, but it's gonna be a headache. So rest in peace. In place of FileZilla, I've switched to using CyberDuck. CyberDuck is free. You just have to register for it, which basically means giving them your email. But it's gonna do basically everything FileZilla did. But to be honest, CyberDuck looks a little cleaner, so maybe it wasn't all so bad. And then finally, Globus. Globus is a file transfer interconnect system. So it has there is an application that you can download and run, or you can access it from the internet. It's also a web-based interface. So we're going to talk about 4 of these. FileZilla not included because yeah, it's gone basically. So here is what MobaXterm's GUI client looks like. If you have MobaXterm open, you're probably familiar with it. It's available on Windows machines. This side panel is what I was talking about. This is the SFTP side panel. So right here, it's going to give you your path. So I think when you log in by default, it's going to throw you in your home. And then there's a yeah, if you go right here and you click this box, this panel will follow wherever you move over here. And that'll be really useful. So you could just see all the files from that you would see like with LS, they'll be over here, and you could right click over here and upload and download files as they come. The SFTP session I was talking about is going to be right here in this little box right here, this button. You click session and then you click SFTP, and then you're going to put in the information that you put in if you're making an SSH session. So the host name, your username, the port number will be 22, and then you can log in and it'll give you a panel that looks like this. Okay, so I do have a slide on files also. So this is what an SFTP session looks like. You have your local machine on one side, and you have your remote machine on another side. So this is my MacBook on this side. This is my Ada files on the other side. You can get this kind of looking SFTP session from MOBA Exterm using that session thing. We skipped over WinSCP. WinSCP is available on Windows machines. This is what it looks like. So you set it up just like this. The host name is going to be whatever computer you're connected to, ada.tamu.edu, terra.tamu.edu. Port number is going to be 22 for all of these. Your username, your password, and then you log in. And then WinSCP, similar to FileZilla and all these clients, it's going to give you a two-pane window like this. Typically with local and then remote on local on your left, remote on your right, but that doesn't exactly always follow through. Allows for transfers to the GUI. Again, here's FileZilla, the prodigal son. So here, like from here, I could just drag and drop stuff from Finder onto Ada, or just drag stuff from Ada onto my local machine. Two-factor makes FileZilla hard to use, so rest in peace. But we have CyberDuck now. So CyberDuck looks like this, and I like it because it's dark theme, like my MacBook. So you open a connection right here. You use the same information that you would have used. So host name, port number, username, password. It's going to start the connection, and then this is what it looks like. This gives you a one-pane little solution here, and it shows you the files on the destination that you've selected, and then you can upload, download files, refresh, all that good stuff. Again, CyberDuck available on Windows and Mac, so if you want something that you could use across both machines, CyberDuck's going to be your go-to. And then lastly, Globus. So the way Globus works is it's web-based with an application you can download. So the application is optional if you want it. You don't need it. Globus shines when making transfers between two hosts. So if you have a lot of files on Terra that you want to migrate to Ada, or vice versa, you have a lot of files on Ada, you want to migrate to Terra, this is where Globus comes in. So you can access Globus by going to see. Let me close this. Over here, we're going to go to globus.org. This is the website. When you log in, you go over here to log in. And let's see. It didn't do it for me because I'm already logged in. Let me do a private session. Globus.org. Okay, so you log in, and then it's going to ask you, is it really going to do this again? Okay, there we go. Great. Look up your university. We go to Texas A&M, continue. And then it does this whole, the CAS authentication. CAS authentication. Okay. So it brings you to this right here. So this file manager says, you want to search for collections. So the collections is going to be the basically the remote host. So there's a whole bunch of different collections. In my case, we want to search for, let's search for Ada. So the collections for Ada are the fast transfer nodes. So Ada-FTN, here we go, 1 and 2. So let's go to the first one. Click here, and now I'm gonna have all of my directory contents. So here's all my Ada stuff. And now if I want to find another endpoint, search all endpoints, let's go to Terra, FTN. We see right here, Oh, this one looks inactive right now. Okay, hold on, wait to file manager. Terra-ftn. There it is. Okay, so now from here, I can manage my files from here. So that's how you use Globus. You could also, I believe the app for Globus is called Globus Connect. You could get that from, there's a way to download it. But it's basically the application version of this web browser right here for downloading files. So again, here's my Terra stuff. And my Ada stuff is over there. This is really good for making transfers between the two nodes. And then the last file transfer solution that we have, which I don't think I mentioned here, but yeah, the next one is the end. You could also browse your files and manage your files from the portal. So the portal being https://portal.hprc.tamil.edu. If you go to the portal, you can select Ada or Terra. Let's go to Ada. Let's see, log in. And then right up here, we see files, and then we can see our home and our scratch directories. So we can actually access our home directories and our scratch directories on Ada and Terra from any web browser. And here we can upload. We could click on a folder and download all this good stuff. So that's file management through the browser. You have two options. You could use Globus, or you could use Ada and Terra's portal. You have all these graphical user interfaces. If you're using, I recommend CyberDuck now. I think Lisa was actually the one who told me about CyberDuck way back when I was mourning the loss of FileZilla, so shout out to her for that. Yeah, that's pretty much all we've got from data management on our clusters. We've got like 7 minutes left, so if anybody has any questions, I will stick around. Otherwise, thank you guys for coming. And I believe we'll have more primers scheduled coming into that webpage, the primers pop-up webpage. So keep an eye out on that and on your email for the list. But I'll stick around for any questions, and thank you guys for coming. Really appreciate it. Do we have a question here? Oh, yeah, that was very